do that while we're talking.
Okay.
Okay, now we're on.
Mm-hmm.
Okay, so we're talking about the degree measure of the central angle of the sector representing the number of workers unemployed for 11 to 14 weeks is that sector. And over here, it's that sector. How much greater is the one on the left than the one on the right?
Wait a minute. Where does it say unemployment? Okay, this. Oh, for at least 1 week. Okay. Got it. Okay.
Well, and we're talking about unemployment for that period.
Right. And is how much greater for the one in that? So.
Well, I hate this question.
You've got.
I do hate this question.
So it's looking for the angle, not the percentage gain,
Well,
right?
exactly. In other words, I would be looking for an answer of double, 100%.
Right.
But that's not what they're talking about. They're talking about the absolute difference in the 2 degrees. That's 10%. That's 5%. That's a difference of 5. Hold on a second.
You have 100. Oh, well, you don't know that no, that's not 180 degree angle. So.
No, it's 5%. How much greater in the manufacturing than in the service? Oh, okay. Here's what I wasn't looking at right there. What's 10% of 10 million?
Oh. 10% of 10 million?
Huh?
Is that's not 1 million, is it?
Yeah. And over here, what is 5% of 8 million? The degree measure is how much greater okay, now I get it. Apologize. What's the degree measure of 10%? In other words, how much is the degree measure all the way around the circle?
Oh, so 10% of 360 degrees?
Yeah, that's 36 degrees.
Oh, okay.
5% of 360 degrees, half that. That's 18 degrees.
So that would be 18, right?
Yeah.
And they need to know how much grade.
Well, and all of their answers are in
It's 18 degrees greater, right? Okay, I got it.
In other words, if some of the answers were in percent,
I get it. It's double, so yeah.
Different, but every answer is in degrees, so it's just the absolute value of that central angle minus the absolute value of that.
Boy, that's tricky.
It is tricky. Very tricky. And let's see, this graph or this picture holds for 4 questions. Just going to be really tricky.
I've got the book, so I'd have to go get it, but I could look at the graph. You wouldn't be able to.
I wouldn't be able to. That's the thing. Question is, can I open this twice? Let's try. Yes, I think I can. Yeah. All right. That'll work.
That's question 10.
Well, that'll work. I end up on this graph. Well, I assumed it was the next page. It's not. Hold on a second. Looking for 18, huh?
22.
Oh, man.
Sorry.
Oh,
I hadn't known that they weren't in order.
that's all right. I'll find 18. I just need to search for it. Oh, that's never a good message. File system error. All right. I think I'm coming to it. Now, I hope it's not page 96. Notice that I'm image 96. I don't know if I didn't.
Oh.
I might not have copied that problem. For some reason, I might have to go back to your original. Yeah, I'm going the wrong way on this.
Let me see if let me check my email and see if I can just send you that one.
Okay. If you can do that, fine. Otherwise, we'll just skip that question and go on to the next.
Okay.
Let's see. That was that one. Okay. So it's after 17.
Oh.
Wow. This is really weird. Can't even do the next one because it refers to a graph that I don't have on here. Well, let's just do this. I don't know that there's any magic in the order of their numbers.
93, 95, 96. Gosh, they didn't load in order either. I'm looking to see if 96 ever loaded, and I don't think it ever did.
Okay. Well, that's probably where 18, 19, and 20 are on that image.
Yeah.
So let's just go to 22, and you can send the other to me at your leisure. We can go over it on Sunday if you want to remind me or whatever. But we don't need to spend time trying to find it right now.
Right.
All right.
What is that symbol?
Well,
operation.
Yeah, that means basically they're inventing a symbol to mean something. It's like inventing a function. And these are very common problems on the SAT. And to figure out what, in other words, that's not a mathematical symbol. That is not. That's just something they invented. And it's defined for all integers as when x, circle x, y, it's equal to that. That's how you define that.
Okay.
So if that's what it is, and x and y can be any integer whatsoever, can x times y minus y be 0? Is this possible? What would have to be true for that to be possible? In other words, can this be 0?
Oh, I see. Okay. Y minus x minus 1 equals, oh, okay. I understand.
So either that can be 0 or that can be 0. And y can certainly be 0.
Right.
So this could be y. I mean, excuse me, that could be 0. Because this means that.
Okay.
Because that's what it says.
I understand now.
X star
because it equals
y.
it. Right.
Yeah, X star, X Texas badge star Y means X1 minus Y. Okay? So
right. Got it.
Means, and yes, that could be 0 if either Y was 0 or X were 1. That would be 0. Now, the second one. Remember, they're asking us which cannot be 0. So the answer is not A.
Mm-hmm.
You just set it equal to 0. What is B?
Mm-hmm.
What is that going to be?
Well,
based on the definition, whatever number on the left goes there, whatever number to the right of the star goes there. So y minus x would be y times x minus x.
why does it switch?
All right, here, let's go back. What this function means, or this definition, star, means that whatever number's on the left goes there. Whatever variable on the right goes there and there.
Okay.
So x star y means x times y minus y. Y star x would be y times x minus
x. Okay. I got it.
And that can also be 0. It only takes x to be 0 or y to be 1.
Correct.
All right. Yeah, they love these problems where they make up these symbols and then they ask you problems. Okay, let's do that one. What does that mean if I were to write it out in this format?
So that would be parentheses x minus 1 times y.
Correct. Minus
y.
Yes. Can that be 0?
Well,
Is that possible? Well, that means
x is 1
minus y minus y. So I have x minus 2y. Can that be 0? Yeah, not too tough. Is all x has to do is be twice y. And that's 0.
Why is x minus 1? Oh, okay. I see what you did.
Because whatever is to the left of the star is right there.
Yeah, I understand that.
Okay.
But when down below you put x minus y, and I hadn't realized what you had done with the parentheses.
And it's the arithmetic. In other words, x minus y is x minus 2y. In other words,
Right.
I distributed that to get that. Oh, hold on, I didn't do it right. Let me do it right. First of all, if I distribute that, I get x, y, minus
xy, right?
Minus another y equals 0.
So xy minus 2y?
Xy minus 2y equals 0. I can still factor the y out, leaving x minus 2 equals 0. And that whole thing is 0 whenever y is 0 or whenever x is 2.
Correct.
All right. So that's not.
So that can't work.
Right. Now we'll go to number D. Well, D says whatever thing is on the left is x plus 1 times the thing on the right minus the thing on the right. And that again is y times x plus 1 minus 1.
Which is 0, which is x, right?
Which is yx equals 0. That can be 0 if either y or x are 0. So I guess I'm done with the problem, although I'm so confused about this problem that I'm not convinced I haven't made a mistake. So I might want to just test the last one and see what the heck's going on here.
Okay.
So this says the number on the left is x. The number on the right is y minus 1 minus the number on the right, which is y minus 1. Have I done that properly? I think I have. X, y minus x minus y plus 1. Question is, can that be 0? Well, that would be what? xy minus x minus y would have to equal negative 1. I'm not sure that that helps looking at it. I guess if I were taking the test, I would have to answer this. Merely because I was able to demonstrate that each of the first 4 could be 0, unless I made a mistake.
Right.
Now, for this to be 0, that would be tough. I can see, I'm trying to think of numbers that would make that equal to 0. And I can't think of any.
I can't either.
In other words, if x were 1 and y were 1, then you would have 1 minus 1 minus 1 plus 1, that is 0. That's not helpful. Because I've tested all 5 questions and it looks like I can make all of them 0. But gosh, I hate that because I love these questions. These questions are not hard. That merely defines a new operation. And it doesn't matter how they want to define it. They're defining it as the number on the left this new operation, the number on the right, means xy minus y.
So I have a question for you.
Yeah. What?
If you have the x times y minus 1 minus y minus 1, couldn't that be 2y minus?
No, that's hard to simplify. I can't really factor anything out of all three numbers or all four numbers.
Oh, I see.
I can't factor anything out of that, and that.
Mm-hmm.
So since I couldn't factor it out, I decided, well, can I think of an x and a y that works? I can't, because if x were 1 and y were 1, then xy is 1 minus another 1 plus 1, that's 0. That's 1 plus 1 is 2, minus 1 and minus 1 is 0. So it appears I can figure out, in other words, what would 1 star 1 be? Be 1 times 1 minus 1. So E appears to work also. I don't want to waste any more time trying to figure out where I've made my mistake, especially since we have one more session and I'll be able to figure it out by then.
Okay. Let's move on then.
Best path is to go on just so we don't waste any more time. I guess I would have to say at this point that if I was taking the test, I would definitely put a check mark here and come back to it.
Right.
But I wouldn't prematurely guess, because I feel like this is a beginner problem and I should be able to get it. I'm not giving up on this problem I'm going to guess yet. This is a problem that I feel like I should know the answer. I should be able to figure it out. So in a way, it's a good illustration of a kind of problem there where you'd want to maybe, you know, if you want to put one check mark by problems that you're just having trouble with and are taking too much time, and 2 check marks by problems that this is so hard I'm never going to figure it out.
Right.
When you come across those kind of problems, I would go ahead and guess. In other words, if I deemed this to be one of the latter, I would guess right now and go on. If I felt like I should be able to figure this out, I don't know why I'm not able to, then I might come back to it and have another look at it. Let's try that.
Okay.
22 is what I'll remember that for Sunday's session. That we'll come back to it. All right, 23. So we have 3 points in a plane, and R is not collinear with P and Q.
Is it possible for you to make the screen a little bigger? Not because of I can't read it, but because it's a little distracting.
Okay.
Just your desktop.
Oh, okay. Oh, I see what's going on here. Apologize, I didn't realize I was doing that. It's amazing how your brain doesn't function that well when you come out of a nap. Oh gosh. All right, we should be able to figure out 23, I hope. Okay, so I have 3 points, P, Q, and R. That's the only way I know they cannot lie, because that would be on a straight line.
Okay.
These are 3 points in a plane, and R says it does not lie on line PQ. So R is somewhere off the line like that.
Okay.
Okay. Which of the following is true about the set of all points in the plane that are the same distance from all 3 points? Well, what kind of a point? If I drew a circle, well, the center of that circle is equidistant from all 3 points.
Mm-hmm.
So right offhand, that would be true. Now, certainly is not a line. That one is not true. It contains
Oh, I see. You checked E. I thought you had crossed out D.
Well, I did cross out D. In other words, right offhand, I can draw a circle through those 3 points. And
right, but your check mark looked as though you had crossed out D, and that's what confused me at first.
I'm sorry. The first time
That's okay.
I drew it, I realized that, yeah, if I had a circle that was like this, then the center of the circle would be equidistant from P, Q, and R.
Right.
So a circle definitely works. So the question is, do any of these others work? Just not sure I would spend the time on it. I might just answer circle because it works. And what else am I going to find? I certainly don't want to find a second point that works. Then I would have to guess what the answer is between my 2 points. So once I discover that a circle works, if I was taking this test, I would probably answer E and go on. But since we're tutoring, let's just examine it a little bit more. I know it's not a line for sure, because they say R does not lie on the line PQ. So R certainly could not lie on the straight line PQ.
But is PQ a straight line?
Well, a straight line is any 2 points. So no matter where P is and no matter where Q is, I can draw a straight line between P and Q.
Okay.
And R is not on it.
Got it.
So it's definitely not that. It contains no points. Well, it's not that either because I already found a point.
Right.
It contains 1 point. That's problematic because can I think of any other point? And if I can't, then it only contains 1 point. So we have P, we have Q, we have R. Is there only 1 point? In other words, if I'm looking for all of the points that are equidistant.
Could it be a triangle? Equilateral triangle?
I don't see it myself. In other words, I have to find a point that this distance is the same as that distance is the same as that distance. And the only thing I can think of that satisfies that at the moment is a circle. In other words, if I look down here, there's no way that that point and that point could both be equidistant from P, Q, and R.
Correct.
In other words, from the way I have drawn it, there is only 1 point. I can't even, no, there isn't. Yes, there is. I cannot find a point on this side that is equidistant from all 3 of those points. In other words, I can't find a second point. Oh, this is a very tricky question.
Can it be two answers?
No, there can't. And that's why it's not a circle.
Oh, because they're circles. Right.
Well, it's not a circle because a circle would be, every point on the circle would have to be equidistant from those 3 points. Not just the center. In other words, the answer really isn't a circle. The answer is the center of a circle.
Oh.
So the answer contains but one point. If I draw a circle, every point on that circle is not equidistant from all 3 points. This point here is not equidistant from all 3 points. The only point it is the center of the circle.
Got it.
So if this is the center of the circle, then we would have 2 answers that both worked. Oh, they are so tricky. No, they really are, because it was easy for me to see that we ended up having to have a point that was the center of a circle, so I immediately went to that answer. But the circle is not the same as the center of the circle. The circle, when you talk about a circle, you're actually talking about every point that's on the circle. When I'm talking about a circle, it's in fact, the official definition of a circle is the locus of all points that are equidistant from a single point. That is the definition of a circle. But what that is, the definition of the circle is the outside, not any point inside. That is a circle right there. And that circle is not equidistant from all 3 points. What is the center of that circle only.
That makes sense.
All right. Oh. Hold on. Just a second. That was 91. And that was questions 22. Done that one. Done this one. Done that one. Guess the way to go here is just to go until we come to a page we haven't done, and then we can answer that. I think this qualifies. I don't believe we've done this one.
Oh, that's the 20 that we were looking for.
Oh.
But we don't know where 19 is, right?
That's okay. Oh, you're right. Oh, this is going to refer to the chart.
Right.
Oh, my goodness. Okay. I can do that.
And you can see the chart.
I can.
From the other page.
Not yet, but in a moment here. Well.
But you can't really read the problem.
There we go. Is this correct? Yes. This is for problems. What's the top of that say? This is for problems 17 through 20, I think. And this is 20. Now, you're right. I can't.
But you can't read it.
Can you? Do you have the book in front of you?
Let me get it.
What's the top line say?
Any idea what page that is?
I do not. I can't read a page number off this at all.
Section 5 of test 2, I think it is.
I think so, yeah. Number 20. This is probably the first section.
No, it's section 2 of test 1. So let me see.
Okay.
Ah.
This should be relatively easy. I can almost figure out what that top line is. They want
That was practice test.
They want the ratio of people who are unemployed.
Oh, I see it. Okay.
Okay, what is it?
The ratio of the number of manufacturing industry workers who were unemployed for 5 to 10 weeks to the number of service industry workers who were unemployed for 5 to 10 weeks is closest to which of the following?
Okay. Since these are in percents, there is, excuse me, wrong one. I don't know how to, that might be an eraser. Okay. That's
that would be
the first
20%,
part, right?
Yes.
The second part is this part right here.
16%.
Well, we don't want to compare the percents.
Right.
We want to compare the number of workers. So 20% of 10 million is 200,000 divided by 16% of 8 million, which is 124. 8 times 16 is 128,000. So there's the ratio we're dealing with. 200 over 128. That is, that is 100 over 64, which is 50 over 32, which is 25 over 16.
Which is, you can't say is 5 over 4. 5 to 4. A.
No, that's not 5/4.
Oh.
Unfortunately, I don't think that reduces. What's 8 times 16? I think I must have done no, that's 128. Do you have your calculator? What's 200 divided by 128?
I do. $1.5625.
1.56. That's not that. It's not that. It's not that. It's not that. It's not that. And now I can read the top of that question. What's going on here? Hold on. Oh, I see why I couldn't read it, because that X was in the way. Now I still can't. Okay, now I can read it. The ratio of the number of manufacturer industry workers who were unemployed is 20% of 10 million. Huh? Okay, that's 2 million, not 200,000. So that's 2 million. Don't think that's going to make any difference. Compared to the number of service industry workers who are unemployed. And that is 16% of 8 million which is 1.28 million. Still end up with 200 divided by 128. What am I missing here? Length of unemployment. If we did just the percentages, then we would get 5 to 4. So I guess if I was taking the test, I would say, okay, I'll put the ratio of the percentages and come up with this answer. And yet, that doesn't seem to me the right way to do this problem, because it says the number of manufacturing industry workers, which to me says 20% of 10 million. In other words, I'm not supposed to compare the percentages because the service industry only has 8 million people. And the manufacturing industry has 10 million people. So if I'm comparing the absolute number of unemployed workers versus the unemployed workers of the other, it would be 2 million versus 1.28 million, which doesn't give me any of those answers.
So what they say here is you've got the numbers, the 200 over 1,
okay.
200 whatever, the 200 over
128.
And they say the ratio of the two numbers is 2 to 1.28.
Huh.
And now you have to see which choice is closest to the ratio of 2 to 1.28.
And I don't see anything there that is close to that.
So then you express it as a fraction of 2 over 1.28, which is equal to the decimal 1.5625, which is what you got.
But it's not equal
so then it
to those
does,
ratios, is it?
Huh?
Is 2
That's
divided
not
by
the answer.
1.28 the equivalent of any of these?
Well, that's what it says. So then you do them as fractions, and 5 divided by 4 is equal to 1.25. 6 over 5 is equal to 1.2. 3 over 2 is equal to 1.5. 5 over 2 is equal to 2.5. 7 over 6 is equal to 1.17. Choice C is closest to 1.5625.
Closest. Okay. I guess that's a good thing, because this, I can't tell you how many
You're
times.
on the right track.
Well, I can't tell you how many times this has happened to me when I'm reviewing GMAT or GRE with somebody. And that is that I miss a key word.
Uh-huh.
Okay, and the key word is closest. I was looking for the ratio.
Mm-hmm.
And that ratio, 2 over 1.28, does not equal any of those ratios. So I got completely confused and started thinking that, wow, am I supposed to compare the percentages, or am I comparing absolute numbers? And the whole reason I was confused is because I didn't see the word closest to. I was looking for the exact answer. So yes, whatever that ratio is, you would figure out the decimal answer of each of these ratios, and whichever one was the closest to it, that's the one that you would pick.
Right.
So, okay, I get it now.
You were on the right track. It's just,
it's not such a bad mistake. to make because it illustrates something very critical. And that is that you got to read every word. In fact, I have gone to the extent where I teach people that if you see a key word in the problem, underline it.
Yeah.
Because if you underline a key word in the problem, then you won't miss it. In other words, while I was reading that problem, it actually would have behooved me to underline the word closest.
Yes.
Because I'm so used to problems where it's not that hard to figure out the exact ratio.
Yeah.
So why would they even have a question that said closest? Only because they're testing your ability to read with accuracy and detail. And
yep.
I flunked it. That test. All right, let's look at 21. Well, all right. Thank goodness, an easy one.
Just plug in the numbers.
I say that facetiously because I'm not having very much luck with these hard ones. But this one I can figure out. How are we going to do this? Because this is the one where the answers are all in squares, which means there can be more than one answer. So we really have to test every single answer.
Exactly.
So it does A work.
So that would be -6, but the absolute value is 6. So yes, that works.
Does B work?
-6 is -3. That does not work.
Does C?
-2 plus 3, no.
D?
No.
How about E?
That's equal, so no.
Exactly. And how about F?
So F.
So there's 2 answers there. That was 95. So I want to go to 96. I don't have 96.
That's the one that's
97. We'll just go and figure out what we're missing.
Didn't we do this one?
I don't think we did. No, it does not look familiar to me.
No, we didn't. Not with the exponents.
Okay. But this should be relatively easy. When I see a problem like this, I know that I can do it because I can pick some numbers. And it has to be true. Well, that makes it a little more complicated because the numbers I pick, it could be true, but it doesn't have to be true. Well, so the easiest way to handle something like that is to make sure you pick, I was going to say positive and negative numbers, but now I'm looking at it, I can only pick negative numbers. So give me a number for y that satisfies this.
Let's try -1.
And a number for x.
Make it easy, -2.
So that would be true. And now we've got is -1 y plus 1 less than -2? It is not.
No.
Is -1 minus 1 less than -2? It is not.
No.
Is xy squared. That would be -1.
Wait a minute. If -1 minus -1, wouldn't that be
Let's go.
-1?
I did the wrong thing for number 2, didn't I? Yeah. In other words, this is -1 minus 1. Is that less than -2? No, it actually is not. In other words, that's -2 is not less than -2. So B is not correct.
But am I correct that it's -1 plus -1?
Yes, you are. Which means negative.
Okay.
That's
just making sure
yeah, that's -2. I did make a mistake, but it turns out that that is not correct anyway. So
okay.
The next one, let's try that one. X is -2. And y is -1, but y squared is +1. And is that less than -2? Well,
no.
no.
Well, no, it's not.
No, it isn't. So no matter what, that's not true. So let's try D.
And we said B is not true, right?
That's -2 times -1. And that is not less than -1 squared. Because that would mean 2 is less than 1, and it's not. So the answer is E. I go on to the next question, but just let's prove it. E would be -2 times -1. Is that less than -2 squared, which is 4? And
yes.
It is. Now, that would not normally be enough for me to prove that. I'd want to try some other numbers also. But usually when you have a situation like that, you want to try positive numbers to make sure that they work. But in this case, x and y have to both be negative. So I don't have a lot of
because they gave that in
try. Yeah, so I mean, I already proved that A, B, C, and D do not work for these two numbers. So I really don't have to disprove those. I've disproved A, B, C, and D. And I have found a set of numbers for E. That's all the proof I need. That means it must be. Just from an algebraic point of view, the way I would proceed would be this. xy minus x squared has to be less than 0. I would factor out an x, and I would get y minus x has to be less than 0. And that's only true if these are opposite signs. In other words, this has to be an opposite sign of that. And the two numbers that we picked, it is. That's negative, that's positive. So I don't know that that necessarily helps much. But I don't think we need to prove it. In other words, it's, and anybody that does this problem is going to pick -1 and -2. They're not going to pick any other set of numbers. I mean, I suppose somebody could pick -1/2 for y and -1 for x, but why would you introduce fractions? You might as well use the two smallest integer numbers you can find, which are -1 and -2. And that's all we need, really, to disprove A, B, C, and D. And it works for E, therefore it must be true for E.
Okay.
Just from a logic point of view.
I think our time is up.
Really? I did so poorly. Well, we started about 1:45. Okay, that's fine. I'm happy to quit here. I just want to make sure I gave you a full hour, Carolyn.
I think you did.
Gosh, I'm so sorry. I feel
it's okay.
I feel bad. That doesn't happen to me very often, but it does happen about once a month where I fall asleep after a big lunch and I don't make my afternoon appointment, and I wake up and usually the person calls me and that's what wakes me up. In your particular case, my son had called me. I was on the phone with my son. I was looking at the clock and I was saying, wow, I think I had a 3 o'clock today. And then I hung up and answered the phone for you. But anyway,
so on Sunday, I will be in Boulder.
Okay.
And I cannot guarantee what my internet connection will be, but I'll still be able to meet with you.
Okay. Well, I will just go ahead and text you the meeting ID on Sunday at the normal time. And
sure.
If you can log on and we have an internet connection, fine. Otherwise, give me a call and we'll figure out what to do.
Okay, great. Thank you.
All right, Carolyn. Talk to you on Sunday.
Bye.
Bye-bye.
Okay, bye.